Hello everyone. In this video, I will talk about two methods, indicating factor and linear equation. Okay, this video continue from the first video. Okay, let's take a look at the first method, which is indicating factor. Okay, sometimes when we have a function of first ODE, and then we can find an indicating factor and then multiply into that first ODE. After we multiply that indicating factor into the first ODE, we can solve that function by using exact equation. Okay, uh, that this method we call indicating factor. Okay, let's look at the theorem first. Okay, this is the function of first ODE m, which is the function of x and y plus n, also function of x and y times dy over dx equal to 0, and this function is not exact equation. Okay. And mu is the integrating factor. Okay, and then we take mu multiply the function of m and n, okay, and set to 0. Then this function is going to be exact equation. Okay, so how we gonna do it? Okay, how we gonna find mu? Okay, take a look at this step. First, you rewrite the equation in this form, which is m function of x and y and plus n function of x and y times dy over dx equal to 0. Okay, you find curve m over curve y and also curve n over curve x. Okay, see, n over x and m over y. You have to remember this. If m partial diff of m over partial diff of y not equal to partial n, equal to curve n over curve x. Okay, if these they are equal, then we can use the exact equation to solve it. If not, consider this follow, which is you have to find the integrating factor. Okay, so how we gonna do? So after you find the curve n over curve y and curve m over curve y and curve n over curve x, then you subtract. Look at this form: curve n over curve y minus curve n over curve x over n. So just divided by n, the n function, which is from here. Okay, if the results are equal to function of x, like a function of x only, which means like for example, like it can be a constant like 1 2 3, something like this. It's also a function of x, or it's a like like 2x equal to 4x squared. So these are like example of a function of x. Okay, so then the integrating factor here is the mu equal to e to the integration of fx dx. Okay, so fx here is from here, fx. So now if it's not a function of x only, then you have to try another one. Okay, so if from the previous slide, if it's not a function of x only, try this one. So curve m over curve y minus curve n over curve x, this is the same, but this one you divided by m, function of m. Okay, so and look at the results. If the result is a function of y only, okay, then the integrating factor is going to be e to the integration of minus this function, this is g1y, or this function dy. Okay, so it's when you get the results function of y only, the same thing, like it can be a constant, for example, like 1, 2, 3 or something like this, or a function of y, which is some, for example, like y, like y square, like 3y, 4y, this is a function of y. And don't forget to have the minus sign here. Or you can do this form, which is you switch n and m. It's going to be cur n over cur x minus cur m over cur y over m. And this is also a function of y. So then if you switch, then the minus sign is gone. You're going to get the integrating factor, which is the mu equal to e to the integration of g2y dy. Okay, let's take a look at example. Okay, in this example, we have 4xy plus 3y squared minus x, okay, in this parenthesis dx. X is go with m, okay, dx is go with m, go with function of m, plus x time, in this parenthesis is x plus 2y dy. So dy is a function of n. Okay, you do the differentiation of each function, you know, dx divided by dy, okay, in this term, like per m, you know, do partial differentiation of function of m with dy, just switching, you know, dy here, dx go to here. So you're gonna get, you do differentiation of this, you get like in the first term you get 4x, right, and this one is 6y, and in this term you multiply x into this in this parenthesis first, you're gonna get x squared plus 2xy, and differentiate with dx, you're gonna get 2x plus 2y. Okay, in this you can see the results. The first term and the second term, they are not the same, so this is not exact equation. So let's try to find the integrating factor. Okay, you take cur m over cur y minus cur n over cur x, and see the result. Here we get 2x plus 4y. And now what's next? Let's try divided by n first, or you can do other way, like you can divide it by m first, doesn't matter. In this case we divided by n, okay, 2x plus 4y divided by n function. N function is here is x times x plus 2y, so you can get like 2 over x. See, here is a function of x only, you don't see y here in this form, so this can be a function of x only. Okay, so now we have to find the integrating factor. So integrating factor is going to go to be e to the integration of the function of x, which is 2 over x dx. You do integration, here you get ln x and 2, like e to the 2 ln x. So it's going to be ln x squared, e to the ln, if you can cross it out, we're going to get x squared, right? So x squared is the integrating factor. Now the next step is you take the integrating factor, multiply into the problem, the first ODE form. So you multiply into it, and we get 4x to the third y plus 3x squared y squared minus x to the third times dx plus x to the fourth plus 2x to the third y dy equal to 0. So now, in this case, it's gonna be exact equation. So now you just find the combination of each one, because it's already exact equation. So the most simple way is you multiply the x and dy into the parentheses of each. Okay. After you multiply, you're gonna get this term and this term, x to the third dx. This is function of x only, dx. So you can do the integration x to the fourth dy. And this contain x and y, so it's coming from duv. Okay. And this also is coming from duv and this duv. So now find the right combination. Okay, from here we get the combination of x to the fourth and dy. Okay, the most simple way that I told you before is you look at the power of each one. This is to the third and this is x to the fourth. So the difference between x, it should be only one. The power, the difference between the power of each term, it should be only one. Okay, this could be the combination. And this one, x to the third, the combination should be x to the second, or it can go to x to the fourth. Okay, in any case, if you don't know the combination yet, this term can go to it can go with this term or this term, right? So now let's look at y. Y different can be x. Sorry, this is power 1, so it can go to y to the zeros and y to the second, so can go to this form and this form, right? So now you have to think, if you do the differentiation of dy and dx, what's the result you're gonna get. You have to try it out. Okay, I'm sure if you do like many times, and you will see like how to find the right combination of each one. Okay, just try it. Okay, in this case we get this form and go with this term, and this term go with this one. So the first term is x to the fourth dy, x to the fourth times y, and this one is x to the third y square. Okay, and this one a function of x only, you can do the integration. So after do integration, we get x to the fourth y plus x to the third y square. Okay, minus this one is x to the fourth over 4 equal to a constant. So this is the final result. Okay, now look at the second example. Okay, here we have y time in this parenthesis x plus y plus 1 time dx. So dx is function of m plus x time in this parenthesis x plus 3y plus 2 dy. dy is go with function of n equal to 0. Now we follow the step of the integrating factor or exact equation is the same. So try the partial derivative of n and m. Okay, let's do it. Okay, do the curve m over curve y first, and for the first term here, you multiply y into the parentheses. We're gonna get xy plus y squared plus y, right? So when you do differentiation over dy, the first term we get x, this one y squared we get 2y, this one y we get 1. Okay. And do the partial partial derivative of function n over the x. Here we get x squared plus 3xy plus 2x, right? So do partial derivative over the x, we're gonna get x squared. Here we get 2x plus, in this form we get 3y, and this one is we get 2. Compare this and this, they're not the same, right? So it's not gonna be exact equation. Okay, let's try the integrating factor. First, try to find the integrating factor mu. Okay, you take the curve m over curve y minus curve n over curve x, right? And you get minus x minus y minus 1. Okay, this is the result. And then divided by n, the function of n here. So it looks very complicated, right? We have y, x, and y. So this is not a function of x only. Okay, let's go to the next step, which is let's see if it's a function of y only. Okay, and you divide it by m in this case. Okay, minus x minus y minus 1 divided by a function of m. M is here, so we're gonna get, just try it, and we can get minus 1 over y. So this is a function of y only. So now we can find the integrating factor. Okay, now find the integrating factor. Okay, integrating factor equal to e to the minus. Don't forget the minus sign because this is a function of y only. Gy dy. Gy is equal to minus 1 over y dy. Okay, minus times minus is go to plus signs. So we're gonna get e to integration of 1 over y dy. Integration of 1 over y dy, we get ln y. So e to the ln y, we're gonna get y only. Okay, now take the integrating factor, which is y, multiply back into the problem or the first ODE. Okay, from the previous slides. You multiply y into each term, to every term. We get this line, this form. Now remember, if you after you multiply the integrating factor, it's gonna be exact equation. So now you just look at the right combination, So in this case, I'll just show you like which one is go with which one. So the deep blue one, y squared times y squared times x dx is go with this form, x y times x squared dy. This red, y to the third dy, y to the third dx go with 3 times y to the second x dy, and this green, y square dx go with 2x y dy. Okay, now when you combine each combination, we're gonna get this one, dx square times y square. And you look at this, there's 1 over 2 here. You know why? Because when you do the differentiation of this term, we're gonna get 2 in front of each term. Just try it out and you will see. So we have to multiply by 2 in order to get the same results with this one. Okay, just write it down and you will see it. And this red circle going to be x times y to the third. And this green, the highest power is y square, go to y square, and the highest power of x is 1, so it's gonna go with x. Okay, so gonna get x and y square. Do the integration of each term, we get this final answer. Okay, and this one we can combine the constant, because there's 2 here. This is the just rearrange it. You don't think about it. Okay, this is the final answer of this problem. Okay, now let's take a look at the second method, which is linear equation. This method we can also use to solve first ODE. Okay, when we have a function of first ODE, something like it can be any form, like this is example. Okay, a function of ax, a function of x only times dy over dx plus bx, b is function of x only times y equal to cx, c is function of x only. And in this case, ax is not equal to 0. So when we have a first ODE function like this, or in other form, we can rearrange. If you can rearrange, this form into this form into the second form, which is uh, in this form we multiply ax into each term, we're gonna get this one is we're gonna get dy over dx plus bx times y over ax equal to cx over ax, right? Also we can write into this form, which is dy over dx is y prime plus px. Px is a function of bx over ax times y equal to qx. Q is cx over ax. If you can rearrange the first form, or other form, which is the first ODE, into the second form, into this one, this is very important one, which is y prime plus px times y equal to qx. Q function of x only and p is function of x only. Then we can use the linear equation method to solve it. Okay, how we do? Okay, how we gonna do? Just look at this px. Okay, look at this px, and remember, I'm gonna skip here to the next slide, and we also skip here. You can read it, but I'm not gonna say it here. Okay, if we can find the integrating factor by using this formula, which is mu x equal to e to the px dx. So after you rewrite and rearrange into the form in the previous slide, take px and plug into this formula, we're gonna get integrating factor. And then you do the same method with the integrating factor, which is you find the integrating factor and then multiply into the problem and then use the exact equation to solve it. Okay, let's take a look at example. Okay, here we have 2 times y minus 4x squared dx plus x dy equal to 0. So in this form, it can be, you can write in any way. But now, if you want to use linear equation, you have to rearrange the form into the linear equation form. Okay, let's do it. So first you multiply 2 into this form, and then divided by the x, you can get 2y minus 8x squared plus x dy over dx. Now, rearranging one more time, you can get x, dy over dx plus 2y. Now, it looks very similar. Okay, equal to 8x squared. Now, the final form is dy over dx plus 2 over x times y equal to 8x. Okay, this is 2 over x here is the px, right? And 8x is qx. Now just take this one, 2 over x, and find the integrating factor. So it's gonna be mu equal to e to the integration of the px function, which is 2 over x here, 2 over x dx. We're gonna get after we do integration, we get 2 ln x e, take, it's gonna be like ln x squared, e to the ln x squared equal to x squared. Now multiply integrating factor into the problem again. From the problem, we're gonna get x squared dy over dx plus 2xy equal to 8x to the third. Okay, you multiply into this one and this one. It doesn't matter, but this one can be easier, I think. Okay, and then it's gonna be exact equation, and no matter how, if you do this method and you can solve this method, it's gonna be exact equation. So just now look at the right combination. Okay, this is a function of x only, so there's no combination. This is x and y. So here it's gonna be duv, right? Look at the highest power. This is x to the second and y power 1. So it must be containing x squared times y power 1. So now you have to prove it. Do the differentiation of this form. If you get the same result with this one. Okay, and it's correct. So we're gonna get dx squared times y minus 8x. We do integration of this one, 8x to the third dx, and do integration of this form. We can get the final answer, which is x square y minus this one. Do integration, we get x to the fourth over 4, 8 over 4, we get 2. We can get, this is the final answer. Okay, so here is you can see the link between exact equation, integrating factor, and linear equation. They are very similar. So the linear equation and integrating factor, you have to find the integrating factor. After you multiply integrating factor into the problem, we can get exact equation. So use the exact equation to solve it. Okay, so this is the end of this clip. You have to review from the first video and this video before to the class. Okay.